right, here we are in part 5 of our section 4, part 5 of the recording. We're going to take a look at symbols and how we may choose to set a scale for different sizes of them. So we're going to talk about enabling scale-based sizing. So I'm going to just type that in, scale-based sizing. And we're going to enable that if our point or line symbols seem really big or too small as we zoom in and out of our map. So let's take a look at our section 3 demo, which is also being used here in section 4. We're going to leave these charts where they are. Let's go back to our Spokane Community College close-up. On this map that we added a whole mess of data to, we had some symbols that actually were kind of funny and disproportionate, if I remember right. I think that was our hoary marmot symbol. So I'm going to turn that on, and then I'm going to right-click and go zoom to layer. So I think we've done that once or twice before, but it's a very useful move that lets you just go right to a layer. There it is. We've got our hoary marmot there. I'm going to go ahead and pin my symbology so it's out of the way for now. So I got this yellow pin, and when I zoom out on the map, this pin is kind of somewhere in the Goat Rocks wilderness. When I zoom out, I feel like, let's see, oh, it's kind of near one of the wolf packs, the Southern Cascades wolf pack. But this pin symbol is kind of big and obnoxious. First off, the symbol is obnoxious. Second of all, the sizing just feels kind of disproportionate. And so what I'm going to do, I'm going to right click and go to Symbology. And let's see, oh, this is set up in special layers because it came from a KML, so that's kind of awkward. Let's see if there's a different way to manage it. Maybe if I right click on Symbol ID and go to Symbology for that. Okay, that's a little bit more straightforward. Okay. All right, so let's go back and do what I just did. Because this came to us from a KML, it's a little bit non-standard. It's going to look a little bit differently. So I'm going to close this. I'm going to show you the steps I went to get to that. First of all, we've got a couple different layers here. When you import data as a KML, it's going to come in a couple different layers of packaging. So our symbol is all the way down here under points, and then it's called Symbol ID. We'll change those names later in our next demonstration, but I'm going to go to the symbology for this last symbol here, and that opens up, apparently this is set on unique values, but it may as well be single symbol because that's just really one point. And when I change it to single symbol, it gives me a nice dot instead of that ugly pin. So that's great. So this can be a single symbol. It's just one spot where we located a marmot. But let's go ahead and change the appearance. So I clicked on that dot to change its appearance. And what I want to do is I want to enable scale-based sizing. And so what that's going to do is it's going to change the size of the marker based on how close I'm zoomed in or out. And Pro will actually do that for you automatically to some degree, but if you want more control over it, this is how we're going to do it. First off, I don't usually like points with an outline around them, so I'm going to give that no color. And again, I'm here in the properties of my symbology. And then let's actually give it a brighter color than, because we already have yellow stars on this map, let's make our marmot purple dot, and then we're going to hit apply, so that's applied. Okay. So now, right now I'm at let's kind of go to one of our standardized scales here. If I hit the arrow here, I can choose a specific scale. I'm going to go to a scale of 1 to 1,000,000. Okay. And I'm going to go ahead and pull my symbology out and pin it so I can look at that. And at a scale of 1 to 1,000,000, so that's 1 to 100 million. Let's see if I can get a 1 to 1,000,000 on here. So I'm going to pull this over to, that's 5 million, 1 to 1 million. So what I'm going to do is I'm going to set up touch points on this sliding scale where I define the size that I want my marker to be. So when I'm at a scale of 1 to a million, like I am here, right now this is a 4-point marker. I feel like that's just a little small. So I'm going to see what a 6-point marker looks like. I feel like that's a little bit, I don't know. I feel like that fits my purpose. Now I've got this label here. We're going to deal with labeling at the very end of this section, so that's kind of a pain, but whatever. So at 1 to a million, I'm going to have a size of 6 point. And then let's look in closer. How about at 1 to 24,000? That's a quad map. Now I just lost my marker. Where'd it go? Boop, boop, boop. Zoom out. Wallop Lake. Yeah, I was there. Okay. So now let's see if I can get it to 1 to quad map size, 1 to 24,000. At 1 to 24,000, how big do I want my dot? Well, this is what a 6-point dot looks like. How about when I zoom in, I get it a little bit bigger, like maybe 10 point? And I'm going to apply that, see what that looks like. Okay, 10 point. Maybe let's see what 12 point looks like. Apply that. Okay, and now I'm going to go ahead and, I just applied scale-based sizing for 1 to a million. So 1 to a million, I still want that to be 6 point. But at 1 to, now I'm going to pull a marker over here at 1 to 24,000. So basically you're defining the size at different scales by clicking and pulling. And when you've got that bar that marks the place on the scale you are, now I'm going to tell it, at this size I want it to be 12 point. And hit that. And then at this very close-up scale, I'm going to have it be even larger. I'm going to have it go all the way up to like 25 point. Apply. And so the idea is now as I zoom in really close, it'll be bigger, and as I zoom out, it's going to be smaller in a good way, so that it's kind of proportional to the map. So basically, the program is going to do this automatically for you to some extent, but when in the cases where you want to have a little bit more control, that's where you do it, at this enable scale-based sizing, and I just kind of showed you what to do. Maybe that's a little advanced for our first foray into symbology, but all right. So, scale-based sizing, yeah. Okay, so this next piece is going to be a little bit more of us just kind of talking and walking through things, and then we'll show some demonstrations just a little bit. We're going to talk about classification methods, and what do I mean when I'm talking about classification? Well, when we come back over here, and we're going to go to our demographics map, and when I'm talking about classification, I'm talking about when we're working in graduated colors or graduated symbols. So let's go ahead and go back to graduated colors here so we can demonstrate some of this. Get ourselves kind of set up. I'm going to zoom out just a little bit so we can see all of Spokane. And there we go. And then I'm not going to be symbolizing based on area of land. I'm going to go back to what we were symbolizing on, which is all poverty households, and those are going to be normalized, also known as divided by the total number of households. Okay, so when I talk about classification, I'm talking about this method here. And what classification is, it's the way that we break data into groups. So just to make this easy for us, I'm also going to change my labels to percentages. So we'll see this one more time. It'll help you remember for the next time you need to do it. Percentage, the number represents a fraction. I'm going to show it as a percentage, and I don't want decimals. So there. Then that's a little easier to interpret for our eyes and for our viewers' eyes. So when I talk about classification, I'm talking about how we break the data into classes. So our default in Pro is going to be to use natural breaks. It's also known as Jenks natural breaks, and the default number of classes is 5. So you can see we have 5 categories here, or 5 classifications of data, from 0 to 7% in poverty, 8 to 18% in poverty, 19 to 32% in poverty, 33 to 48, 49 to 86. And what you're going to notice is these classifications, these classes are not like, it's not like 0 to 5, 6 to 10, you know, to 15 to 20. They're like, I mean, the highest number is 49 all the way up to 86%. So, and the smallest one spans only 0 to 7%. So what's going on here? Well, we're talking about classification. We're going to talk about classification methods. So I'm going to hit this arrow here, and you're going to see that there are different classification methods. I want you to have a basic understanding of those methods. It's how we're looking at this data. So let's come here into the PDF. We'll mess around a little bit more later. But effective classification, absolutely, it influences the way that your viewer is going to see the data. So it can make patterns in your data more clear, or it can obscure patterns in your data. So you can use classification to kind of make the data say kind of what you want it to say. Improper classification can be confusing or even misleading. And so it's our job to do our best to make clear classification. So the default, like I said, is natural breaks. And you can use that for graduated colors, for graduated symbols, proportional symbols. If you're unsure about what classification to use, you can start with natural breaks with 5 classes. Okay? And then adjust the number of classes up and down. So in general, you're going to want somewhere between 3 and 7 classes. So 5 is a good place to start. If you get more than 7 classes, that's going to be confusing to your viewer. Our eyes can only differentiate about up to 5 to 7. So if you go over 7 classes, you're pretty much just confusing people. When you go down to 3, you kind of simplify things, but you're probably losing a little bit of information. Let's take a look at this figure down here. So this is actually looking at the percent female population in Spokane County, and that's visualized with graduated colors and natural breaks classification. So this is 5, 10, and 3 classes. And so what you can see at 5 classes, so here we're looking at number of females in the census box. And what you can see here at 5 classes is you see a few places that pop out as let's see, so high female areas, less than 55%. So those are going to be our dark blue. And so you can see some areas, there's an area up here to the north that's disproportionately female. Then we have some lighter areas, right, the downtown core, and then out near Fairchild that have fewer females. And you can kind of see that with 5. If you increase it to 10, do you get any more information? Well, you add kind of some classes here, some lighter and darker, and so you see that over here you actually have fewer females in this area than you do out here, whereas with 5 classes you didn't see that. And then if you bring it down to 3, you kind of get even a little bit different pattern. So still you see that cluster up north, but if you're breaking it down to just 3, you actually see that a lot of the south of Spokane, this is like South Hill area, is a little bit heavier on females, and the downtown core again is more male, and then out here by Fairchild again is more male. But you also see kind of out in the valley, you're seeing more females as well. So the number of classes makes a difference. You can see that the general overall patterns are there, but you can kind of see where the breaks are. What I notice here is between 5 and 10, I don't see a whole lot of difference. And because of that, it's better to go with the 5. So when in doubt, go more simply. If you're not seeing a lot of new patterns, stick with the lower number. Okay, there's my tip for you. So natural breaks looks for groupings that are innate in your data, and it's going to group similar data together while maximizing the difference between groupings. So it's going to maximizing the difference between your groupings. So that's why you get the breaks at these different areas. So it looks like if we were to look back at our real map here, you know, if natural breaks chose to put a break right here at 48%, between 48 and 49, it means that there's a greater frequency, you know, above that. And so you see that, oh, this is a natural clump. And you can kind of look at the histogram, kind of shows you where those are. Scales, we're not going to deal with scales right now, but okay, so another type of classification is quantile classification. So this is going to group the features in your layer into, so you have an equal number of features in each group. Number of features in each group. For example, Spokane County has 105 census tracts. If we classify the layers into 5 groups based on quantiles, each group will include an equal number of tracts. So 105 divided by 5, that's going to be, sorry, I don't know if you can tell, it's late for me. It'd be 105 divided by 5, which should just pop right into my head, but for some reason right now, I'm really tired. 21. Yeah. Oh, yeah, because there's 20 and 100. Yeah. So maybe 21 tracks. And so let's go ahead and take a look at what that actually looks like if we're over here in our data. Let's go ahead and take this, and now let's put it into quantiles. Okay, so we see things a little bit differently. And so basically now, I'm not actually sure how many blocks we have here. I'd need to count them all up. Actually, I could do that. Attribute table. Let's see, we've got 65. And so it's going to be 65 divided by 5. So that's going to be 13. Does that sound right? That's going to be 13 tracks in each of these categories. And so if we were to count these, we would count the same, that number here. And let's fix our labels. We're going to be really good at this at the end. Percentage. None. Okay. And so we've got 0 to 7%, 8 to 12, 13 to 23, 24 to 36, 37 to 86. So you can see that that with quantiles, we still end up with a pretty big spread for our last. Basically, these are the census tracts that have the highest number of households, highest percentage of households in poverty. If we chose 13 of them, these would be the top 13, would range from 37 to 86%. So there's a pretty big spread. The lowest 13 of them would only range from 0 to 7%. So there's that. Okay, so that's quantiles. So we're going to have basically an equal number in each of the groups. If I reduce this all the way down to 3, whoop, it gets rid of my cute labels, but we can kind of see that we see some of the similar patterns. Actually, we don't see a huge difference, and so yeah, that's what you do is you kind of watch. So quantiles are something that sometimes is a little bit easier for people to just intuitively understand. So when you look at the upper quantile and the lower quantile, they include the same number of tracks, and so that's a way that people could understand your symbols. So next, equal interval is probably the simplest way that people just really quick, like a quantile, you kind of have to explain usually a little bit. Like for someone who hasn't spent very much time in statistics, you kind of have to explain what a quantile is. But from an intuitive standpoint, many people just kind of understand when something's in equal intervals. And that's a classification system that's going to create groups that have an equal spread in the data. For lack of a better, I know I meant to have one word there, but I can't remember that one word. But we mean an equal spread in the data. For example, we might look at it's going to have an equal range. So let's just look at this data and symbolize it that way. So instead of quantile, let's do equal interval. And so if we were to, and this is just the default starts with 5, right? Let's go ahead and make these labels easier to interpret. So we're going to go into percentage again. You're going to see this so many times that I'm not going to put any decimal places. And then we'll go back and take a look at it. So basically we're looking at a spread of 17% points here. And if we took just that 17% points, that means that our legend is really easy for someone to follow, right? Oh, it's like each of these are kind of equally spaced. But when we actually look at the data, we look at the map, now just visually only one of our census tracts pulls out as a high poverty, and that's this one between 70 to 86% is right here, kind of still kind of well north, kind of a little bit west central, but a little bit more north. I think this is probably like Division coming up through here, I'm guessing. So a little bit north of downtown. And so we kind of missed some of the information that we thought we saw earlier. So it's just a different way of looking at the data. If we were to take this down to 3, right, we have just kind of a few of these highest poverty areas, and those are going to be from 57 to 86%. And then we've got from 28 to 57 and from 0 to 28. So we're looking at a bit 28% splits there. And if we were to take it up to 10, right, we'd see a little bit different pattern. So you can see we're definitely getting we're getting a different visualization when we go with equal interval than we do when we go with quantiles or when we go with natural breaks. And let's see, next piece. Manual interval. Oh, this lets you get to decide what you want your intervals to be. This is where you can really fudge the data. So we go over here and we can say, I'm going to take it back to like 3. Okay, and I could say, hey, so we go from classes. I just set it up in 3 classes. I'm going to go to the histogram, and I'm going to say, rather than 28%, I want you to have low poverty be defined as anything that's less than. And so you can set your definitions, which is kind of powerful. Let's say I want it at 50, as close to 50 as I can get. 49.99, sure. And so now when you look at the map, and then we'll say high poverty is any block that's like over 75%. Oop. Oh, 74.7, 75.0. Yeah, okay. So now when you look at it, you really just see, oh, well, if you were to just take a glance at it, you'd be like, oh, Spokane has very little poverty. Look at that. Like most of the neighborhoods are really, in this light yellow category. And I could obscure it even more by just, instead of calling these out as numbers, I could title this low poverty, moderate poverty, high poverty, right? And you're missing a lot of information, but that's how manual intervals, I could really obscure the data. And I could say, it's really this one census tract. We need to focus on that one tract. When in fact, it's actually, there's, the story's more complex than that. But anyway, manual interval, you get to decide the intervals that you want. And in some cases, that's going to make sense because you're going to have something that's a defined parameter that's been defined in publications or defined by some criteria. And you're going to use that to set your intervals. So manual interval could be appropriate in that sort of a setting. So let's see here. What tab was that we used? The histogram tab. Yeah. Histogram. Is your brain full yet? We've been blocked here. I guess it's because I've been recording all these. Maybe you're digesting them slower. Geometric interval classes, they're defined based on a geometric series. And so that's kind of a compromise between equal interval and an equal number of features within each interval, or a quantile approach. So geometric interval, we could take a look at that. I think it's still an option. Yeah, there we go. All right, and we could bump it up to, you see a much different picture here, right? Where you're like, oh gosh, there's poverty in this is the Interstate 90 corridor, and then up north along Division. If we were to pull it up to 5 classes, we see something a little bit different still, okay? So, geometric intervals, and then what was I going to show you? So something that's quite a bit different than what we've been looking at before is standard deviation. And this is going to highlight, this is a really useful one. Like when I'm looking for favorites, I like to use natural breaks or standard deviation, depending on what I'm doing, or manual interval if I have some criteria. That if you want to take a minute and take some notes, put a star. Natural breaks, manual interval if I've got like a criteria or something, and it's not just my own ideas. And then standard deviation. So this is going to look at features that are above or below the mean. Okay. So we're looking at things that are greater than average or less than average. Let's take a look at that for this data. So we're going to look at census tracts that are poorer than average or less poor than average as far as the number of households. So let's do that one. And so interval size, 1 standard deviation, or maybe half a standard deviation. You can change this, and then your colors are going to work best if you use a color that's like 2 different colors. So basically what's going to happen is the census tracts that have less poverty are going to show up in brown, and the census tracts that have more poverty are going to show up in blue, if that kind of makes sense. And you can kind of see them here. And it's just by, if you're familiar with like a normal distribution, so this does make some assumptions on the way your data are distributed. But if you're familiar with a normal distribution, kind of that bell-shaped curve, you're basically looking at how far from that central measurement is a tract, and is it greater or less than. So what we can actually see here is we get a little bit more resolution in the data. So we see our census tracts where households are struggling more show up in blue, and then the census tracts where we have less struggle are showing up in the darker browns. And so we're kind of looking at things on 2 different sides of the mean there. And so that can be really useful for looking at some different phenomena. Is it greater than or less than average? It can be interesting to look at things like weather phenomena this way, like temperature or rainfall. So it kind of gives it a little bit more meaning, I think, than just, so 5 inches of rain fell in this area. What does that mean for us? Is it a wet year for them or a dry year? You don't really know unless you kind of know what the mean is. And so this kind of at least gives you a feeling for within that data set what's falling above or below the mean. So I like that one too. Okay, so this is just a figure that is going to show you the same data, and this is represented with the same color scheme and 5 classes, and we're looking at percent female here. And basically I ran it for Spokane County for all the census blocks, and just so you can kind of see, in the workbook you can kind of see, okay, what do these end up looking like? So you've got natural breaks, quantile, equal interval, and you can see that you get quite a bit of difference. Manual interval, well, I just set that up, so that's sort of not fair, but and then geometric interval, and then a standard deviation, so you can see where there's more ladies or fewer ladies. So it is interesting. I think it's kind of, it can be useful to kind of see these. And then another tool for you that I've put in here is I pulled this from Thematic Cartography and Visualization all the way back in 1999. And this helps you kind of looking at criteria for classification, selecting them. So you have the ease of understanding the concept, you have the ease of computing it, the ease of understanding the legend values match range of data in a class, acceptable for ordinal data, so that's data that's not continuous. It's not a continuous measurement where you could be anywhere along the line. But it's, you're either this number or that number or another number. And then assists in selecting the number of classes. And so you've got poor, good, very good, acceptable, unacceptable. And what I would like to point out here, I might minimize this a little bit so we can see the whole table at once. but natural breaks is very good for a lot of things. The thing that natural breaks is not going to be good for is ordinal data. In that case, you want to work with quantiles if you're dealing with just a limited number of options. Yeah, so this is why I start with natural breaks. It's probably the best place to start for much data. Although the legend isn't that great for understanding. Equal interval is great for the legend, but in other things, it's just doesn't really make sense. So, so in general, you're not going to go wrong if you work with natural breaks. But I also recommend dealing with the standard deviation. I think that can be great for pulling out patterns in your data. And I mean, that's what we're trying to do as map makers, is help people to understand patterns in their geographic, the geographic component of some of these patterns. So really fun to get into that census data. And boy, I feel like we're pretty deep for not being very far into this class. Let's see here. So we've got that table to help us, and really the whole classification piece and lecture is a big one, and it's a lot to digest. It's a lot to understand, but kind of giving you like the tip of the iceberg, and then of course if you go farther and you decide, gosh, this GIS stuff is my thing. This data stuff, I get really excited about it, and that sort of thing. You will go on and you'll take geostatistics courses and that sort of thing, and that'll you'll get a deeper understanding. But here's your introduction, okay, to classification systems.